Hi guys, Dr. B here. This is your Finding Empirical Molecular Formulas lecture. The empirical formula, or the simple formula of a chemical compound, is a representation of the simplest whole number ratio between the elements comprising the compound. The formulas of all ionic compounds are empirical formulas. The molecular formula is the representation of the actual whole number ratio between the elements of compounds. So this is important here. The formulas of all, if it's ionic, that's just going to be the empirical formula, meaning it cannot be reduced. You can have a chemical, like a covalent compound, the one that has all nonmetals. It can be the empirical formula, and if they give you certain information, you can derive the molecular formula. And I will talk about that when it comes up. We're going to use this formula here to determine our molecular formula once we have our empirical formula. This lowercase n here, this is a specific number that's going to be distributed through the empirical formula to get the molecular formula. And again, once you see the example, it should make sense. A molecule with a molecular weight of 180.18 grams per mole is analyzed and found to contain 40% carbon, 6.72% hydrogen, and 53.28% oxygen. What are the empirical and molecular formulas of this molecule? So there are a total of 6 steps I'm going to go over bit by bit. So please just pay attention. Step 1, find the number of moles of each element in a sample of the molecule. So this is going to be my work here. Hopefully I have enough space for this. So step 1. Oops. Step 1. So I had 40% of carbon, so I'm going to assume this is going to be in grams. That's an assumption we're going to make. Similar for the 6.72 grams of H, and then 53.28 grams of oxygen. So assume your percents are going to be grams. Then you're going to get the number of moles of each element. So that means you're going to use your molar masses. So 1 mole of carbon over 12.01 grams of carbon. It's going to be approximately 3.33 moles of carbon. 1 mole of hydrogen over 1.008 grams of hydrogen will approximately be 6.67 moles of hydrogen. Now I'll convert my grams of oxygen to moles. So 1 mole of oxygen, just straight up oxygen, is 16 grams of O. It's going to be also 3.33 moles of oxygen. I know we said it's going to always be diatomic, blah blah blah, but we're not dealing with reactions right now. So try to be careful that you don't do that. Probably shouldn't highlight it. Next step. Find the ratios between the number of moles of each element. So that means I'm going to now divide by the smallest number of moles, which is 3.33. It's going to give me 1, 2, and 1. And from here, this is going to give us this was step 2, empirical formula. So my empirical formula, step 3, the empirical formula, the EF, is C1H2O. Step 4, determine the molecular weight, or the empirical formula mass. So it's going to be just getting the mass of your answer from 3. So 12 plus 2 times 1.008 plus 16 will be 30.026 grams per mole. Number 5. Find the number of empirical formula units in the molecular formula. What does that mean? So this is your lowercase n. You're going to divide the molecular weight given in the problem. Divide that by the empirical formula mass that we just got from step number 3. When we divide the two, it's approximately going to be 6. So then now you find the empirical formula by distributing your 6 that you determined through the empirical formula. Please tell me you know what distribute means. So C6H12O6. That's my molecular formula. So empirical formula, just so you can write this down in your notes, CH2O and then C6H12O6. Other examples to go through. So you're going to hear me say, either in class or in lecture, or even when you're reviewing, how many steps this is going to be. So it can either be 1 through 3, 4 through 6, or 1 through 6. And whenever you hear those things, it tells you what you should be doing. So hopefully you paid attention to the 6 steps that we just went over. Determine the empirical formula of an ionic compound of chromium and chlorine, and there's a composition of 42.31% for chromium, and chlorine is 57.69%. So now we have the percent composition. Now we're trying to find the empirical formula. So determine the empirical formula. That means we're only going to do steps 1 through 3 for this thing. So I'll take each of my elements that have the percents. I'm going to assume that those percents are grams, and just divide by the molar mass for each. So this is going to be CR, CL. Okay, so I'll divide the two, and I end up with approximately 0.81 moles of chromium, and then 1.63 moles of chlorine. Step 2 is to determine the ratio of the moles. Divide both of them by the smallest number of moles, 0.81 for each. You end up with 1 and 2. They're really close to 1 and 2, not just like, they're really close. So then you just get your formula, CrCl2. That's it. Calculate the molecular formula of borazine. The percent composition is given, and the molecular mass of borazine is 80.50 grams. Sorry. If you notice, it wants the molecular formula, but it does not give us the empirical formula. That means this has to be steps 1 through 6 because we're not given the empirical formula. So, boron, 40.29 grams divided by the molar mass of it. Let's try N. 52.21 grams divided by 14.01. Hydrogen, 7.50 grams of hydrogen. Divide that by the molar mass of hydrogen. So I do my math. I divide, just do my normal dimensional analysis conversions. 3.73 moles, 3.73 moles, and 7.44 moles when I do my math. I divide by my smallest number. I end up with 1, 1, and 2 when I do my math. So even though this is a lecture and I'm telling you, I'll give it to you online, you should be following along with a calculator and your periodic tables, gentlemen, because if not, you're just kind of wasting your time. So I suggest you do this correctly. So therefore, my empirical formula is going to be B1N1H2. Now, to get the molecular formula, we first have to determine my N, the number I'm going to distribute. But to do that, I need to have my molecular mass that I'm given in the problem. That will be in my numerator. My denominator will be the mass of my empirical formula. So 10.81 times 1 plus 14.01 times 2 plus 2 times 1.008 will give me 26.836. I divide these two, it will come out pretty close to 3. When I say pretty close, whenever I'm saying that, it's going to be like 2.99 or 3.001 or 3.01, something like that. If you have a number that's like 2.5, you're going to have to do something else, and I'll talk about it at the end. If you have numbers that are a little off, like 2.7, 2.8, you may need to recheck your math. Anyway, so I'm going to take this 3 here that I just got, and I will distribute it through my empirical formula to get my molecular formula, B3N3H6. So that's my answer in the question. What am I looking for? My molecular formula. A compound has been isolated and analyzed. The empirical formula of the compound is CH2. Its molar mass is 42.08 grams. What is the molecular formula of the compound? So luckily for us, they just want the molecular formula, and they already given us the empirical formula. So my steps 1 through 3 are already done here. I just want to get the molecular formula. This is going to be steps 4. Oops, didn't do that. 4 through 6. Oops, 4 through 6. All right. So my N equals 42.08 divided by the mass of CH2. So 12.01 plus 2 times 1.008 is going to be 14.026. Just by looking at this, you think it can probably be pretty close to 3. So you're going to take your 3 and distribute it through your empirical formula to get your molecular formula in the end. The empirical formula of a colorless gas is COCl2. Its molar mass is 98.9 grams. What is the molecular formula of the compound? So I want to see you do. I want you to do this by yourself. So I'm going to pause for a little bit. So stop the video, and then we see what we end up getting. Okay. So what is the molecular formula? So we have steps 1 through 3 already taken care of for us. So my N will be my molar mass given in the problem divided by the molar mass of this. And if you did this right, you should end up with something like 98.91, which is approximately 1. Therefore, my molecular formula is COCl2. It doesn't change because I distribute a 1. Important. If your ratio looks something like this, where you divide and you end up with 1 and 1.5, you need to multiply by the least common multiple that would give you whole numbers. Or something, a least common denominator? Yeah. So like, if I were to distribute a number like 1, just saying, I'd have 1 and 1.5. If I distributed a 3, I would have Fe3, but then O4.5. So I have to distribute a 2. This will become Fe2O3. Wow, that's bad. So you may see some like this. So just try to keep this in mind when you're doing this. If you end up, when you're getting the ratios, you end up with a number like that, make sure you are aware of those things. All right, that's it for now. Let me know if you have any questions. Thanks.